Hello, in this video we're looking at differentiating inverse trig functions. So we've already looked at how to differentiate sine, cos, tan, cot, sec and cosec. So now we're going to look at how we might differentiate arc sine, arc cos, etc. So there are 6 altogether we could look at. In this video we're going to be looking at arc sine, arc tan and arc sec. The others are similar and you can work them out. So if we're told that y is equal to arc sine x and we want to differentiate it, that means that we want a formula for dy by dx in terms of x preferably. So this is how we go about it. So as we say, these are the inverse trig functions. So by definition, if y is equal to arc sine x, that means that x is equal to sine y. Differentiating that with respect to y gives us dx by dy is equal to cos y. And then we can reciprocate that. So dy by dx is equal to 1 over cos y. Now, we already know from our trig identities that sine squared y plus cos squared y is equal to 1, which means that cos y can be rewritten as the square root of 1 minus sine squared y. And as we know from earlier, sine y is the same as x, which means that dy by dx is the same as or is equal to 1 over the square root of 1 minus x squared. Now we'll look at y equals arc tan x, and in the same way, we can straight away write that x is equal to tan y, and we can differentiate both sides with respect to y and get dx by dy equals sec squared y, and hence dy by dx is the reciprocal, it's 1 over sec squared y. So this time we're going to look at another one of our trig identities. It's the one that says that tan squared y plus 1 is equal to sec squared y, and the reason we want to do that is because this question was all about tan. So if we replace sec squared y with tan squared y plus 1, we can then replace the tan y with x, and we get that if y equals arc tan x, then dy by dx is equal to 1 over x squared plus 1. And then finally, if y equals arc sec x, then x equals sec y, and again we know that if we differentiate sec y with respect to y, we're going to get sec y tan y, which we reciprocate, so dy by dx is equal to 1 over sec y tan y. But we want to do it in terms of x if we can. Sec y itself is alright because we know that will be x, but for the tan y, again using the same substitution as in the previous slide, we know that tan squared y plus 1 equals sec squared y. So tan y itself is the square root of sec squared y minus 1. So now we've got everything in terms of sec y's, and we can replace the sec y's with x's. So dy by dx is equal to 1 over x times the square root of x squared minus 1.